All right. Thank you very much for inviting me to discuss this interesting paper. So I'm just going to briefly go through the model, discuss the implications for observables, give some intuition, and then give some comments. Okay, so the model. So there's equity holders. They employ a continuum of workers. So the workers will be indexed by I. And the equity holders have this production technology. YT, capital YT, is aggregate productivity, and H is the workers' human capital that they bring, and then that produces output. This match produces output, little y. Now, the equity holders decide how much to pay the worker, the compensation, and how much to invest in keeping the worker. And the worker decides to stay or to leave. Now, even if the worker decides to stay, the match might be dissolved with a probability that's under the control of the equity holders, the investment. Now, if the worker remains employed, the human capital in expectation stays the same, but it's subject to idiosyncratic shocks, epsilon. Otherwise, the human capital declines at rate lambda. Okay, so there's lots of interesting numerical targets. I'm going to focus actually here on the equity premium. This is a really interesting, rich model. There's a lot of things going on. And so because of the brief time that I have, I'll talk about the forces that allow this model to explain the equity premium puzzle. Okay, so more on the model. So what I gave before is kind of the general framework. It's a pretty natural, simple framework, actually. The specific assumptions are that both the workers and the equity holders have a preference for early resolution of uncertainty. And the other assumption is that aggregate productivity shocks are persistent. So there's a two-state Markov process with a low and a high state. Then the idiosyncratic risk depends on the aggregate state. So basically, if you're in a low state, you have the idiosyncratic risk has this fat left tail. Okay, so now you might ask, well, are we really still trying to solve the equity premium puzzle? I mean, didn't Bonsall and Yaron show in a model really in many ways like this model, so persistent risk in output, recursive utility with a preference for early resolution of uncertainty? Didn't we know that this explained the equity premium puzzle? Well, not so fast. So the puzzle, the sort of further puzzle is when you have a production economy, it gets pretty hard to retain this result. And that was due to Kaltenbrenner and Wachter. So I think the first result in this paper is basically to recover a Kaltenbrenner and Wachter type result, which is to say that when you have full commitment, you don't get an equity premium. And essentially, the result is that the equity premium, which is the return on the dividend claim, is basically zero. Now, why is that? I just want to take a minute to review the basic intuition. So let's say you're in this bad state. You're in this low growth state. What that does is it means the continuation value of the match falls, and the equity holders are going to reduce their investment in the match. That means dividends, which is what the equity holders consume, rise. So basically, you have these two forces. One is counter-cyclical dividends. The other is counter-cyclical consumption of the equity holders. Now, equity holders are still sad when G equals GL. I mean, their marginal utility is still high, but it's dampened by the fact that they're consuming more because they're investing less. So in a way, the equity holders are kind of getting around this long-run risk. And so the aim here is to, in a way, sort of stop them from doing that. Okay, so how does that work here? So by the way, that intuition, I've shown how it works in this model, but it's very general intuition in production economy. Okay, so this is a model with limited commitment. So first of all, we have a value of a contract, and that takes a familiar form where the value today is equal to the payoff, which is the output. You take out some for the investment, and then you take out the compensation for the worker. And then you have next period's value. Kappa is the probability the worker stays alive. Theta is the probability the worker stays in the firm. Then you have the stochastic discount value, next stochastic discount factor, and next period's value. The point is that equity holders, as I mentioned before, choose the compensation and the investment theta to maximize the value of the match. Now, here are their constraints. They can't force the worker to stay, so the worker's utility, and this is UT and U bar T are very complicated expressions. They have, but in any case, the worker has to, it has to be in the interest of the worker to stay, and then the firm value is non-negative. And basically, the worker's utility depends on, if the worker stays, it's on C, and on the future value of the match. If the worker leaves, then it's on the unemployment benefits and the value if the worker is in the labor market. Okay, so the first is, well, it works. So the equity premium is 6% in the data. It's 3.5% in the model, which is a lot bigger than basically 0, which it was if you don't have any commitment. And so the question is, why exactly is this the case? And so as I was reading this paper, several possibilities came to mind. The first thing I thought is that maybe this is like Constantinides and Duffy counter-cyclical labor income risk. And there is a parallel here, but it's really not exactly the same. So the idiosyncratic labor income risk story is that there's workers that face idiosyncratic labor income risk. They don't want to invest in equity because their idiosyncratic risk worsens basically in bad economic times when equity goes down in value. This is not exactly what's going on here, because for the reason that workers actually don't invest in equity. It's a limited participation model. Only the equity holders invest in equity. So this can't be what's happening. Now that may actually be a good thing because so my colleague Sylvain Catherine shows that if you look at investors on a dollar-weighted basis, they're not really subject to labor income risk. Now, by the way, this paper does have a mechanism to generate counter-cyclical labor income, basically worse labor income risk in bad times. I guess you'd call that counter-cyclical labor income risk. And that's nice that they can match that in the data. But that alone, and Henry talked about this, does not help with the equity premium. Okay, so it's not bad. It's not that workers are afraid of equity doing badly in bad times for their labor income. That's not what's going on. So then I thought, oh, well, maybe it's wage rigidity. Maybe it's because of the workers' participation constraint. You need to compensate them to stay in the match during bad times. And so the firms need to insure the workers. And by insuring the workers, we wind up with wage rigidity. Well, that's not it either, because first of all, if you take this model and you basically keep the SDF the same, and you just keep the wages whatever they are, so that's called exogenous wage rigidity, you get nothing at all. And worker side limited commitment gives you something very, very small. So this was a really interesting set of results that I think the authors provided. All these different counterfactuals. Okay, so I was actually really surprised by this result because why is it that wage rigidity does not at least help with the equity premium? So really my hypothesis here is that, okay, the firms are insuring the risk-averse workers. This makes dividends more volatile relative to output and consumption more volatile to output. And they're doing this in order to keep the workers in the match. But that's actually not what's going on. And I believe the reason is that it's actually not hard in a sense to keep the workers in the match because the workers' outside option scales up with the risk. I think that's basically a modeling choice to make things easier. So this model is not a model of rigid wages in the traditional sense. There really isn't traditional wage rigidity in this model. That's why it doesn't help. That's why just taking these wages and putting them in the equity premium does nothing. So that's not exactly what's going on here. So what's going on actually is something very different, and it's new, and that's really neat. Workers' human capital is subject to idiosyncratic shocks, as we've seen. The equity holder, who's also risk averse, is diversified. Now, under full commitment, the equity holder can completely insure the workers against these shocks, and therefore can put forward a very efficient contract to keep the worker in the firm. And basically, the equity holder needs to pay less in wages. However, if the equity holder can't efficiently insure the worker, then the equity holder has to pay more in wages to keep the worker and the firm. And there are times at which this insurance becomes expensive. So I guess the way to think about it is there are certain times when workers might want to leave because they're concerned about the ability of the firm, of the equity holder, to invest in them. So they're thinking of leaving. Now, the equity holder would like to keep the workers in the firm. And it basically becomes very expensive to do so because the workers are so worried about this continuation value in the firm, and they know that the equity holder can't commit to keep them. So basically, it is this imperfect insurance. It is endogenous incomplete risk sharing. Basically, the equity premium doesn't come from the incomplete risk sharing from the worker, but the undiversifiability of the labor risk in the worker translates over to the firm. Okay, now on to asset pricing. So asset pricing, it always relies on the Euler equation. In this model, the Euler equation becomes volatile because equity holders are forced to have long-run risk and consumption, and together with Epstein's and utility. And you can say that R is volatile in part because of this. I'm simplifying here, but also because of long-run risk and dividends. I think it's great to have like a theory model that has these numerical targets, and then I just have to mention the sort of traditional objections to this framework because there's specific evidence against long-run risk and of consumption, and evidence against long-run risk and dividends, and in fact, even evidence against Epstein's and utility. So I suppose one way to read this is, if you look at the post-war data, the equity holders in this model are worried about something that's really never occurred in the United States. And maybe it's occurred in Japan or Russia, but they're worried about something that's actually never happened. Now, maybe it could happen, so that would be a different interpretation. However, even then, you're still kind of up against the fact that there's accumulating evidence against Epstein's and utility in other asset classes. So these are traditional concerns. One could raise other concerns ultimately. So this model does rely on limited participation. If the workers were allowed to participate, I think that would mitigate some of the things that are causing the equity premium here. Ultimately, we want to explain that, that may be a cognitive limitation, but then how do we say that some people have it and some people don't? I also might conjecture that introducing physical capital would weaken these results. So that would be another concern. However, just to close, I think this paper really has a surprising and interesting result that limited firm side commitment raises risk to equity holders. I don't think I ever would have expected that. I think it's really neat that the authors can show that. I think it's especially valuable that they don't just conjecture that this is true, but they show that it actually can be quantitatively significant. No paper can do everything. I think the traditional concerns that I outlined, they're still there. I think that the equity premium, it's clearly a hard puzzle. I mean, I think what's sort of fun about it is, like, I'll just leave you with the thought that there's a solution out there, and we just don't know what it is yet. All right, thank you.